Hello and welcome back to the final episode of my world map tutorial series. Today's topic will be adding waypoints to the map that you can discover in the world and then left click on the map to fast travel to them. Before we start, like with all of my other tutorial series, the download link for the completed project will be found in the video description of this episode, and the project also contains the features that we will add in this episode. So if anything isn't working for you or you just want access to the final project, make sure to check that out. Apart from that, there is another important information for you. So just a couple of days ago there was a patch for version 4.20, which is now called 4.20.1, which includes a bunch of hotfixes to known issues. I had a quick look at the world map project, and upgrading the engine will not break anything, at least in the world map projects, so feel free to upgrade to follow along. To get started with our waypoint system, let's go into our actors folder, and we will start with creating the blueprint class that will later be placed in the world to represent our waypoints. Let's add a new blueprint class of type actor called BP_waypoint, and let's go in there. Just to have something like a visual representation of our waypoint, we will add a component which is called a billboard. So basically that's just a simple sprite, so we can easily identify the position of our waypoint. And let's just uncheck the hidden in game, so that way we can see this little sprite when we're actually playing. Then we only need one more component, and that will be a sphere collision, which we will call something like discover range. So once our player enters that sphere, we will discover the waypoint and display it on the map. Let's give it something like a blue shape color, so we're able to distinguish it from the other sphere collisions we're using. And that's it already for the components. We also need one variable here, so we can control the radius of a sphere. Let's just call that the discover radius. And we'll make that a float, editable and exposed on spawn, so we can easily control it per actor. And we'll put it in a category called settings. Let's give that a default, maybe 200 Unreal units will be the default size. And to make this variable have an impact, we'll go to the construction script and say we want to grab the discover range and set its radius to our discover radius. And we don't need to check for overlaps, so let's uncheck that. Then we'll head over to the event graph, and once our waypoint has been discovered, there is no need to further check for collision of the discover range. So let's add a custom event here called onDiscovered. The only thing we'll do is getting our discover range, and we want to destroy this component. Let's compile and save. We can minimize the BP waypoint for now and return later to implement the collision events of a discover range. For now, let's continue with the actual widget. So if we have a look at our textures folder, there is an icon_travel point. So that will be used for our waypoint widget. And like I said, we want to be able to click it in order to fast travel to the matching location. So we know that this needs to become a button. All right, let's head over to our widgets folder and create a new user interface widget blueprint called W_waypoint. Then we can open that up and start to lay out our design. So we don't need a canvas panel, and this widget doesn't need to fill the screen. It can be desired on screen. We will need a size box. Like with our other markers, the size here will change when we're zooming in and out. Let's check width and height override. Let's set that to something like 19 by 24. That should be half of the original size of the icon. And this size box needs to be a variable, so let's call that waypoint size box and check is variable. Then in there we will add a button and call that waypoint button. We will need to uncheck the is focusable. If this was checked and we click the W_waypoint, it would try to read the keyboard input. For example, if you click it once and then hit spacebar, you would click it a second time, because hovering over this button would then make it the focus of your input. So that's something we don't want here. Then we'll go to style, normal, and look for our icon_travel point. And we will draw that as an image. We can copy this style for hovered and pressed. And let's go to hovered, and we will select a very bright orange here. Let's say we can drag this onto our palette, so we got access to the color. We will use the same color for normal, but this time just slightly lower the alpha to 0.6 maybe. And then we'll go to pressed, select the same color and just make it a bit darker. Alright, so that's it for the design of our widget. We can also remove the padding here for normal and press, don't need that. If you select your button and scroll down, we can already implement the event on clicked, but we'll add the functionality later. Can't do that right now. Instead, we need a bunch of variables in here. So first off, this waypoint needs to know about the map. So let's call that map reference. And the type here will simply be the bpc_worldMap object reference. We will tell this widget about it when we spawn it. So let's make it editable and expose on spawn. Then we'll add another variable, which will be the size. And so far there have been widgets where we used two variables, which were size in X and size in Y and so on. But it might be a lot easier to just use a vector 2D here, which means the X value of that will store the width of our widget and the Y value the height. Then let's make that editable and expose on spawn. We need another variable of type integer that we'll call the index, and make it editable and expose on spawn too. Then compile and save. We will also need one function to update the size, so simply call that update size. One input, which will simply be the new size, so also type vector 2D and call it something like new size. What we have to do here is very simple. We just update our variables, so set size to the input, and to apply the changes we will get our waypoint size box and set width override, and after that set height override. Let's hook these up to the execution, and to grab the values we simply drag in our size variable, break it, and then we can simply use X for width and Y for height. Compile and save. Then in our event graph we can remove event construct and tick, and for pre-construct we will call the update size function with the new size being our size variable. Compile and save. We will return to this widget in a second. For now let's also minimize it. And we need to be able to place this waypoint onto our map. So let's open up our w_worldMap. And like we did for the areas, we need a separate overlay which will store the waypoints. So that way we can make sure that all of the waypoints we will dynamically add will stay beneath the player box and markers that will eventually be placed, but will be in front of the background and the areas overlay. Alright, let's look for an overlay. Drag that onto your map overlay and right beneath the areas overlay. Then let's call that waypoints overlay and make it a variable. It will need to fill out the entire space here. And we need a function to add waypoint widgets. So let's head over to the graph, add a new function called add waypoint widget. This needs a bunch of inputs. So first off, we need to know about the size. So a vector 2D. That we will call size. Then we need another vector 2D, which will be the starting position. After that, we need to know about the index, so an integer called index. And finally, we need to know about the map component, so the BPC world map reference that we'll just call map. Since we're creating a widget here, would be good to return it. So let's add an output of type w_waypoint reference. You can call that out or whatever you want. And the logic here is very simple. We will create widget of class w_waypoint. Then we'll hook up the size from our input as well as the index and the map. After that, we will grab our waypoints overlay and add child to overlay, the content being the return value here. Then to apply the position, we'll drag off the return value and set render translation to the in position. And after that, we will go into the return node with the out being the return value of our create node. There's no more logic required in here, so let's close the w_worldMap and we will head over to our actors and to the BPC world map. Now in here we need a bunch of variables. So first off, we will store an array of all of the discovered waypoints. So let's add a variable discovered waypoints. The type here will simply be our blueprint class, so bp underscore waypoint reference, and like I said, the type will be an array. Can make it private. Then we will keep track of the current size of waypoints, which might change depending on whether we're zooming in or not. So let's add a variable called waypoint size. Type here will be a simple vector 2D, and it won't be an array but a single variable, private. Then there is a second array we need to keep track of, which contains all of the widgets associated with the discovered waypoints. So waypoint widgets. Type here will be w underscore waypoint reference and an array, again private. These are the three private variables that we need, and there will also be some new settings that we'll add now. Let's start with the default waypoint size. So just the starting value of the waypoint size variable. Type here will be a vector 2D, and it will be a single variable, editable, exposed on spawn, and in the settings category. Then we'll add another variable, which we will call keep waypoint size when zooming ? Remember that we created a similar variable for the player and marker size, so that needs to be a boolean 2, editable, exposed on spawn, and in our settings category. And the last variable will be called default waypoints. So basically our player has to discover waypoints in the world so that they appear on the map, but we will say that there are some default waypoints that are visible on the map by default. So the type here will be bp underscore waypoint object reference, and the type that we're choosing here is not an array but a set. Since we have not worked with sets in this series before, let me quickly explain these. So a set is basically just an array in the sense that you're storing multiple entries of the same variable type, but you're not able to have copies in a set. So that means there can't be two instances of the same waypoint in this set, which is good for us. And a set doesn't really care about the order of the elements. So you don't have access to an index, but you're just worrying about whether a certain element is contained in there. Make it editable, exposed on spawn, put it in settings. Then we can compile and save. And there is one variable here that needs a default value, which is our default waypoint size. We will simply use the size of the texture for our waypoint icon, which are 38 pixel in X and 48 in Y. Then we can compile and save. And let's add a quick function, which we will call discover waypoint. Of course, this needs an input of what waypoint has been discovered. So a bp underscore waypoint called waypoint. We can start by grabbing our discovered waypoints and check whether that array already contains the element we're trying to add. And we could go for an if statement here, but just to be able to use the true path for the preceding logic, I will add a not boolean to the contains and hook that up to the branch. So that way the false path here means that the waypoint we're trying to discover is already included in our array, and that means we can't do anything, so simply return. But if it wasn't included so far, so the true path, we will grab our discovered waypoints and add the input as a new element. Then we will create a widget for it, so we grab the map reference and add waypoint widget. That will be asking for a bunch of variables, so the size will simply be our waypoint size variable. The index will come from our add node, so the return value here. The map will be a reference to ourselves. And for the position, we will call the function location to map position and hook that up. It's asking for a widget size, so that will still be the waypoint size. And for the location, we will grab the input and simply call get actor location. After that, we can grab the waypoint widgets array, add an element there, which will simply be the return value of our function. And finally, we will drag a pin off of the waypoint and call onDiscovered, so the event we added in there. After that, we can return and compile and save. Then when we're trying to zoom in, we need to update the positions of our markers. So let's add a function called update waypoint positions. The logic here is very similar to what we scripted in the episodes before. So we grab the discovered waypoints and run it for each loop. Then for every element, we will need to check whether there is a widget associated with it. So grab your waypoint widgets, get from it, add the array index, and call isValid. That up to the loop body. If it is, we can drag off of it and set the render translation. And to get that, we will simply call location to map position, widget size being the waypoint size, and location being the actual location of our array element. Once that loop is completed, we can return. And basically we also need functionality to update the waypoint sizes when zooming, and that function is very similar to what we did here. So we will simply duplicate update waypoint positions and call it update waypoint sizes. The only thing we'll remove here is the set render translation, and instead we will call update size, with the new size being our waypoint size variable. Now we only have to call these two functions when zooming in, so in our modify map size function. Let's move to the very end here and add a little bit of space. Drag in our keep waypoint size when zooming and add a branch. If it's false, that means we have to modify the size, so we will set the waypoint size, and its new value will simply be the default waypoint size multiplied by a float, and that float is the current size multiplier. Hook that up to the new waypoint size, and after that we will call update waypoint sizes. Once we've updated the sizes, we also need to update the waypoint positions, and updating the waypoint positions is also necessary when we're keeping the size when zooming, so hook that up to the true path, and after it we may go into our return node. Compile and save. Then let's head over to our event graph and look for some room. Here we will add a custom event called onWaypointClicked. So that will handle fast traveling to the matching location. Let's add an input of type integer called index, just to identify which waypoint was pressed. Then drag in your discovered waypoints, get from it, add the input index, check whether it's valid. If it is, we will teleport our player, so drag in your player and call setActorLocation. For the new location, we will get our discovered waypoint here, get actor location, and instead of just plugging in this vector, we will also call traceDown world location and hook that up. That will simply enable us to, for example, put the waypoint in one of our platforms here, and instead of teleporting the player into that platform, our function will trace down the actual location and put him on the platform. So that way we can just avoid some issues that might appear. Now we have changed the player location. However, the player did not actually move or jump, and that means the location on the map would no longer be correct. So we will call update player position on map. Compile and save. Then in our initialize map event here, currently here where we're setting available colors and marker sizes, let's add some space, because we also need to set the waypoint size to the original value, so the default waypoint size. And what we also want to do is that when the game starts, we want to discover all of the waypoints in the default waypoints set. So here let's add a bit of space, grab your default waypoints, and we'll call a function called toArray and hook that up to the completed of our for each loop. Then for the array, we'll run another for each loop, and for every element included there, we will call discover waypoint and hook up the array element as the waypoint. Then when that is completed, we'll go into show map and add to viewport. All right, that's it for our components so far. Let's head back to our w_waypoint. Now we can implement the onClicked, because we will simply grab the map reference and call onWaypointClicked, with the index being our internal index variable. All right. Compile, save that and close it. Then in our BP waypoint, we can implement the collision of our discover range. So let's scroll down and look for onComponent begin overlap. Let's check whether the actor we are overlapping owns a map component. So get component by class being the BPC_world map. Then off of the return value, add an isValid node. And if it is valid, we can drag off of the return value, so the map component, and call discover waypoint, with the waypoint being a reference to self. Alright, so that should already be working. Let's close our classes. And somewhere in the level, maybe here, we will drag in a BP waypoint and just increase the discover radius by a bit. And also move it up so we can see the billboard. And then we'll also add a waypoint here. And the last one maybe at the very end of our parcours, so here. Now if we were to start our little game, we can actually see the billboard of our waypoint. Let's open up the map. And once we move close to it, it appears on our map. We can hover it and it will actually change the style. Now once I press it, our player will be teleported to the matching location. And let's maybe discover another waypoint here. And I can click them to fast travel between these two locations. Let's select our third-person character and its player map, because now we've got access to the default waypoints set. Let's add an element there and select our BP waypoint 3, so the last one we added at the very end of the level. Now when we hit play and open up our map, we can see that by default our third waypoint here is visible. We can click it to fast travel to it, and then from here we can discover the other waypoints. For example, the second one over here. We can fast travel between these two by just clicking them, and if we zoom in and out, we can see that the size of them is also modified properly and their position is being updated. Alright, so that's it for adding the feature of waypoints. Before wrapping up this entire series, there is one bug that I want to fix. Let me quickly show you this bug. So if we play and open up our map, we can use the left mouse button to pan around our map by default. That is actually not something that is supposed to happen. We wanted to make it so that when zooming in and when the map size becomes larger than the size of the window, that only then we're able to drag it around. The cause of this lies in our BPC world map in the map out of boundaries function. Here we're currently using the function getDesiredSize. The problem with that is that the desired size is not equal to the actual size of a widget. It is only equal to it when the size of your viewport is 1920 by 1080, which was the default resolution we're using for all of our widgets. But when we're playing this level in a new window, we are using different sizes there, and that way we can no longer correctly use the getDesiredSize function. So to work around this, let's add a function to get the actual size of a widget. So we'll just call that getWidgetSize. Give it one input, just of the type widget. So this one here, object reference, called widget. And it will have one output, which will be the size. And that will be a vector 2D. We can also make this a pure function since it just returns something. Then let's split the output, and we have to do a little bit of math here. So first off, let's start by grabbing our widget and getting the desired size. Then we will break that to get X and Y. We also need to get our viewport size, break that. And we have to get the X here and divide that by a float, which will be 1920, and divide the Y by another float, which will be 1080. And what that means is simply that we're getting the percentage of size of our current viewport compared to the default size when working with widgets, which is 1920 by 1080 in our case. And we can use this percentage to calculate the actual size. And to do that, simply grab the X of the desired size of your widget and multiply that by the X of the viewport size divided by 1920. And do the same thing for Y. So multiply that by a float, and we'll multiply that by the division by 1080 and plug these in for X and Y. So that way you calculate the actual size of a widget, and we can fix our issue by going back to the map out of boundaries, and we will replace the desired size here by getWidgetSize. Hook up our map reference and the size to the break vector. Then if we were to compile and save and play the game, open up our map. I'm trying to hold down the left mouse button and drag around, but nothing happens. So that is what we wanted to achieve, and once I'm zooming in, I'll be able to control the map using the left mouse button and dragging. Then when I zoom out, I'm no longer able to do that. Alright, that is the end of this episode and of the series as a whole. Remember the download link in the video description, and I hope this series has been helpful for you, and see you in the next video.